Hello dear viewers, welcome to this tutorial. Today we are going to talk about modular programming using functions. Here is the scope of this tutorial. The first thing that we get to explore is to see what is a function, what are the benefits of using a function, what are the function terminologies, how does function works, what is the lifetime of a variable in a function, and finally we'll be having a take-home of storage classes or variables, and also calling by value and by reference. And last but not least, we'll be seeing what we mean by a recursive function. Let's get started. When we say a function is nothing other than a set or a piece of code. Usually, when we say a function, it is nothing other than a named, independent, and reusable set of codes, and this set of codes will be able to satisfy or to solve a specific problem, which means we are going to go step by step. When we say named, it means a function should have a specific name. For example, int add. It is unnamed because this function is having the name which is called add. It is independent. Independent why? Because here we can have many functions, and if we are having these two functions, this one is independent because whatever this one is doing, this sub will not know what add is doing. It is reusable why? Because here I can call add function, and this add function I can call it more than once, which means if I want to use the statement written in add function, I don't need to rewrite these statements. I will only call this function. So it is a set of code that solves a specific problem. Why? Because here, if we are having this addition function, we are expecting this function to be used only in order to add numbers. If we are having subtraction function, we are expecting the statement from this subtraction function to be used in only subtracting some operand or some numbers, which means this function is solving a specific problem. Let's go to the next thing. What are the benefits of using function? Usually, as we have said, it is an independent that performs a specific task. There are some benefits from this. Usually, modular programming has been used due to the huge complexity of the problematics that needs also many codes, and it was very difficult to debug those codes because there were many. So then they have said, let us just develop or even implement a technique whereby we'll be having set of codes, modules, all like what we call function. We can have one module. For example, let me say, for example, it is campus management system. This campus management system, it is a huge problem, a complex one, and it is very difficult to develop a one application to manage the campus without functions, which means then we can subdivide some modules from campus management system. For example, we can have the module for registration, we can have the module for viewing the transcript, we can have the module for suspension, something like that. So which means each and every module is there to satisfy, to solve a specific need. So which means then those modules, they can also refer to functions. So which means then, so the benefits of function also include like this breaking a large computing into smaller ones, as I said, with this divide and conquer, which means you can take one big question, one big issue or one big project, you divide it into some smaller and easy to solve work so that you can be able to implement those simple and small works. Thereafter, you put them together back to be a very big solution to that big problem. So it avoids the need of redundant programming. Usually, you don't repeat the codes. We have seen that it is a reusable set of codes. So you can only call, as I have been showing you this one. It increases also the logical clarity of the program. Because each and every time when you want, for example, to access to addition, this is an example. When you have add, subtract, division, when you are having any problem in add, it will not impact subtraction or division, because we have seen that it is independent. So here also the clarity will be there. Why? Because if you're having any bug from add, it is very clear for you so that you can go to add, then you fix the bug. It specifically takes the user to build a customized library of frequently used routines. It also promotes portability, which means you can be able to move a function from one place to another. Okay, so then these are the benefits of functions then. Usually the theory of functions is divide and conquer. Usually it constructs a program from smaller pieces of or component. These smaller pieces then, this is what we call modules, and each piece more manageable than original program. Yes, usually those modules, those pieces of your program or those components or those simple and smaller parts of your program, they are very manageable more than the original program. So this was for the function definition. So let us go to terminologies. In terminologies, I want to talk about some things. The first one, it is function. Sorry, here we can have the prototype. What do you mean by a prototype? Here I'm going to have an example. So for example, here I am having my int main, and in my main I am calling one function, and here I am returning something. Let me return, for example, 0. And from here I am having another function called int add. This int add of mine, this is one function starting from here to here. This is another function which is int add. So this function, it is defined thereafter main, which means before main, because here in my main I may need to call this function. So which means as long as I'm calling it here in my main, I need then to declare it before main. But then the declaration or the definition of this function is here down, which means I need to prototype this one. Prototyping is nothing other than giving an example of something before its definition or its manufacturing. So which means here this is what we mean by function prototype. In function prototype, you take the function return type together with the function name. Inside you need to have your prototypes or your parameters, sorry, then your parameters should be pasted there. If you are having, for example, here int age, so which means here also you need to put int age here. But if you don't have it, so you can leave it. Prototyping usually is nothing other than something that contains the name of the function, the return type, and also a list of variables that must be passed in it, and the type of variables it returns, if any. which is this one. This is what we mean by function prototype. Okay, after function prototype, we can just take a look at function definition. The function definition, when you say function definition, usually function definition itself is called function definition, and the function definition should contain the codes that will be executed. Like here, I can say I'm having int a and int b. So what are we going to return? We can return something like a plus b, which means this is what we mean by function definition. It will contain the codes that will need to be executed. So what do we mean then by function header? So when we say function header, it is the one that is taken or it is copied in prototyping your function. The function header is at the start of your function and it gives the function name. The header also gives the function's return type and describe its argument. Note that the function header is identical to function prototype minus the semicolons, which means the function header, it is this one that is selected. And if you want to prototype, you only take the function header, then you add a semicolon. Then the function body is the statement or the list of things that will be done in there. So I think then we can talk about the arguments and also the return statement and also the parameters. When you say parameters, for example, here I can say, for example, here I am having int x and y. This is it. And here we are having our function here. As you can see, this is our function to add. And here I'm having this good. So remember, these parameters should be the same. So this is what we call parameters. Parameters is the list of variables passed at definition of a function, and the argument, it is the list of variables passed at the calling. So for example here, I can call this y by x and y. You can see here it was a and b, which was parameters, and here also we are having these arguments. So it is not always a rule that we need to, if here you've declared your function with a and b, you can also call it with the x and y. The only main thing that you need to make sure is that the data types are the same. Otherwise, you can change the names as you want. So these are the arguments. Then we can talk about the return statement. This function here, it is returning something of type integer. So here also in the return, you need to return something of type integer. The same as here, integer, then you need to return 0, but 0, we remember that it is an integer. So let us go practically. What is this one? We are going to practice on this one. So I will not take much longer in these things, but what I want only is just to show how everything works. So the first thing, as we have seen it before, that we need to do, it is this one. So here we know that our main is a function, and this function we can give it void or something that we want. And if we have given it a void, so it means we don't really need to return something. But if it is int as I want it to be, I need to return something of type integer. And here this integer that I'm passing is nothing other than this 0 of mine. Okay, after returning this, after writing this one, so here we can have many things. Let me say, for example, I can tell to the user printf enter the two numbers. So here I need to receive those numbers, And if I am going to receive this number, remember I need to pass here the data type specifiers, and here also my num1 and num2. These things, they need to be declared before getting used. We know that before going to a hotel, in order to occupy the room, you need to allocate or to book the room. So which means then I need to book or declare this one. Remember, if it is numerical values that you are receiving, you need to provide this ampersand. Okay, so I have finished to receive this one, and here then I can ask to the user printf, let me say, do you want to add them, something like this, and if so, then I can take something like this, then I can return num1 and num2, but then with this per. But here, as you can see, let me not even just do this. Let me not use this one, but let me print if addition of num1 and num2 is, then here I can have this num. Okay, let me just make it like this. Is equal to this one plus this one, which is this. Okay, I am done right now. So you can see that as I have done for addition, I can do it for subtraction, for division, for modulus, and so on and so forth. But here I can say, for example, okay, I can say this is it, num1, num2, num1 plus num2, and here, other than doing like this, I can do it like this, then plus num2 is equal to num1 plus num2, which is this one. For example, this is it. If it is for subtraction, then you can also do the subtraction. But here, the reason why I want to bring this one here, so here there is a problem. You can read the message. The message says there is something before num1, so something that we are forgetting before num1. Okay, we need to read always the errors that has been given to us. Enter the two numbers. If I just give like this one, so it will just, okay, the addition of this one and this one is equal to this one. So but as you can see here, if I want to add, for example, subtraction, sorry, if I want to put subtraction there, then I can write subtraction of two numbers. Then here I will only just change the sign, and here also the sign. Here also it is addition of two numbers. Let me put this /n for the view. So enter the two numbers. So let me say, for example, this is the one. So the addition is this one, the subtraction of this number. I need to only change the message. So if you take this one minus this one, you get this one. Okay, but then the problem, you can see that we are not keeping track to each and every as we want or as we wish. We need first of all to know, what am I going to do, what am I not going to do. So this is why then this one that we are writing here, it is better that we don't do it here, but then they becomes specific functions. Here I need to come here, so this one, these two, they are for addition, this two is for subtraction, which means I can have my int add, int a, and int b. So after this, I can get this one and I get this one. Other than doing this, so I can say int sum is equal to a plus b. All I can only say like this. Then I say sum is equal to a plus b. Then because my function, it was for the type integer, then I can return something like sum. So if I am doing it like that, so you can see this is my function for sum. Here also I can have another function for subtraction. So whatever that I'm doing here, it is only here subtraction, then here in subs, and your subs is the one that will be getting or having the output. Then I will be done. You can see here I can create, so this is the function for subtraction, the function for addition. So after this one, then you can have int num1 and num2. Thereafter, after receiving them, I can say then result add result is equal to, and then I call this function. After calling this function, then I will pass my num1 and num2. So after this one, I can then print out this one. Let us give it a try, and then we see. The sum of percentage d plus percentage d is equal to percentage d. So which means then here I can have this one, then together with add result. So here will be done. So which means I am able to call this function of mine, which is add. So if you run like your program like this, so it will tell me that this one is not declared. I need to declare it first. After that, then I can call it here. So here it is telling me that I am not putting the semicolon at the end. So after this, the same here, the same here. Okay, now I'm okay. So enter the two numbers. Let me say, for example, 45 and 34. So you can see that the summation is working very perfectly. So here then, as long as we can see this one, wow, here Remember, we have seen and we have studied conditional statements, so we can also apply these ones here. So as long as we are having like this one, so I can have something like printf press 1 for addition /n 2 for subtraction 3 for exit. This is an example, and here after doing this, I can then declare another variable called choice. Then I am going to receive the choice that the user has entered. So ch, then after receiving this ch, I can then switch my ch. Then after switching my ch, which means I will be having some cases, case 1, and in my case 1 it is where I will be doing the other thing. So after this I can break, then after I can have case 2. In my case 2, nothing else other than this one I'll be doing. So here I can have sub of these two numbers, and other than doing this I will just pass this one. We have this function, and this sub, other than having this one, I can have it like this. Even here there's no meaning of this word. Okay, I copy this and I paste it here. So wow, I am done. So you can see that now everything is fine. I can also have my case 3, and in my case 3 I can put like exit. Okay, so now I can also have my default, and in my default I can print out something, wrong choice. So like right now it is very easy. Why? Because I am able to keep track to everything, and here it is better that I put a while loop, and my while loop I will do wherever once it is 1 until I am done. Okay, well, very good. Now I'm fine. So you can see now this sub, usually the sub, it should be declared here. Usually this is the practice for functions. Enter the two numbers, I can enter these ones, then it will ask me place 1 for addition, then it will tell me this one, place 2 for subtraction. You can see for the subtraction is this one, place 3 for exit. Usually you can see that we are able to keep track to everything. So as long as you are not exiting from the system will always give you the prompt for you to choose. I think you are getting my point. You will always be able to keep track to this. And if you just, okay, here for example, I can do it like this, and even after exit I can put it like this, something like this. And if usually these are for the design, enter the two numbers. These are the two numbers. Place 1 for addition, 2 for subtraction, 3 for exit, 1 for addition. Then it will tell me the addition is this one. Let me 35. It will tell me wrong choice. Please try again later. You can add any other thing. Subtraction, for example, I will press 2. You can see the subtraction is possible. If I press 2 again, it will be the same because it is not doing it cumulatively. It is only using the other entered numbers. If I press 3, it will then go out from the system. So usually what I wanted to show you is then the usage of these functions. It is reusable because I can call it many times as I want. Okay, you can even just add many other functions. So right now, as you can see, my system is not giving me an error, but in most of the times, you may even have an error because you are calling this function, for example, subs function, before its definition. The definition is down, which means I need to take these ones and come here to prototype them here, which means I am finishing to prototype this one. I need also to come here and also take this one in order to prototype it here. So this is what we mean by prototyping. This is what we mean by function headers, and this is what we mean by function definition, all statements of my function. So here, as you can see, we can be able to keep track to this one, to these functions. You can add as many functions as you want, but when you want to call them, you need to call them inside your main. Yes, so after this, we were talking about the theory, which was construct a program from smaller pieces or component, and this is smaller pieces are called what we've called modules, and each piece more manageable than the original program. We've talked about this one. So we've said that the library, it is nothing other than a set of predefined functions that can be called from any library that is already published. And here we have said that, for example, in printf is found in IO. This is why we have implemented or just taken or used this stdio. If you want to use math library, it means then you need to come here, then you import math.h, which means if you want to use, for example, square root, you can be able to use the square root. You can, okay, let me say, for example, here at the end, before this one, I can print out something like the square root of num1 is something, but for the square root, okay, let me just do it like this and then I see if it works. Yeah, let me say num1, which is then sqrt num1. Let me try this and then I see. Enter the two numbers. So if I press 3, usually, okay, it is going. Okay, this is for exit. Well, this one I can also just, okay, let me cut this. and I bring it here. For example, it's only a try that you want to see if it works. So you can see that the square root of this one is this one. Why this? You can see now it's okay. The square root of this one is this one. Okay, you can see that you can be able to use this function, but if I by error I remove this one and I run, you can see now it will not work. Why is it working? Okay, sometimes this comes like a built-in, but also we need to make sure that, okay, let me put like cosine to see if it is not another issue. Okay, the square root of 20 is this one. Okay, please, usually sometimes it works or it gives you some wrong numbers, but it is because it is the updated compiler, but it needs to throw an error. Well and good. So let us just talk about then calling a function. Here, this part is already done. And here we also said that a variable in a function, the lifetime of a variable in a function is within the function. And if you want one variable to be used in many functions, then you can use global variables. The storages, we have done it. And let us just go to call by value or call by reference. When we say reference, you understand pointers, and if you say value, you need to understand normal and simple and real values. Okay, let me say for example call by, let us just talk about this calling by value. Let me say here, you can see we've created a variable, and these variables, when we wanted to call them, we called them by their values, which means when it is for the value, usually the actual parameters will be copied in formal parameters, and these two functions, usually these two ones will be having different locations. Let us have a simple example. For us to understand, it is better that we use some examples. Okay. So this is, for example, call by value. So I am having the two functions which are add and subtract. So I'm going to change these ones as to make them too simple and too small. I'm making them too small. Okay. This one also, it does. Okay, it is like this. Let me then just work on like this and add a is go to this. Let me say for example, before returning anything, Let me say, for example, a is equal to 20, okay, and b is equal to 10. What we understand, we have created variables a and b, and in the memory we have assigned 20 to the variable a and 10 to the variable b. Okay, in then calling, I am going to say, for example, int x, int a is equal to 20 or to 10, and int b is equal to 20. Then if we print out the value of a, it will give you this new value, which is 20, and I am going to give it a try, and the value of b is this one. Let me try. So you can see the value of a is 10 and the value of b is 20, which are these ones. So usually what I can tell you guys, this is the way, the normal way that we are using, the same as we are using here. This is calling by value. We don't use the addresses of the variables in order to call these values. But when we say calling by reference, usually calling by reference, it will change the initial. Let me say, for example, this is my int add, and it is having this pointer a, and this pointer b. And here we are saying then the value of a, let it be equal to 20, and the value of b, let it be equal to 10. And here I'm declaring a and b here. Then I am calling, I can call the function which is add, and when I am adding, I can add then from the address of a and the address of b. I am calling like only this one. So when I print, then printing the value of a and the value of b, what will be the case from here? Then you can see it will tell me it is 20 and 10. Why? Because usually I am calling by the reference, and here whatever I can change here, whatever I can assign here, this one will always be having the value from that address, which means calling by value, it will take the current values into the variables. By calling by reference, it will take the leo and the collect value from the definition time. This is what we mean by calling by value and calling by reference. And here when you say calling by value and calling by reference, it is something that we will be using much more into this one. So okay, let us go to the last point of this presentation, whereby we are going to talk about recursion. And when you say recursion, is nothing other than a function calling itself. We can have for the factorials, we can have anything, but we need first of all to see then how does everything works before going to recursions. So the first thing that we need to know is the correct and the real work of something before converting that function into recursive function. Let me say that we want to search for the factorial of a number. We know that if you want, for example, to search for the factorial of 5, it is equal to 5 times 4 times 3 times 2 times 1, which means it is like all the previous numbers by applying the multiplication on them. So the way we can do it, we can say, okay, if the number entered is less than 0, it will say that it's impossible for negatives. Otherwise, we will say that factorial is equal to factorial times I, and then here we'll be going here to I plus plus, then we'll be stopping when I is less than or equal to A, which means A is the entered number, and we need then to move until we reaches to that number, so which means it is the same. If there's a entered 5, so it will be 1 times 2 times 3 times 4 times 5, which is this one. Okay, here if for example you enter any number, I think it is 0, the last one I have mistaken. Let me try to do this. If it is like this, if I enter 5, the factorial of 5 is 0. Let me see. Okay, 0, it is not. Okay, 0 times I, so factorial which was 1 0 0 0 0 0. So okay, the problem is this one. I need to start from 1 just because 0 is not also allowed. So if you have like this, if I enter for example 3, it will be 1 times 2 times 3, which is equal to 6. If I enter for example 5, I hope this system should give me 120. Yes, this is for the factorials. Then how can I then change this function into a recursive function? A recursive function is nothing other than a function calling itself. So here I can say if a is greater than 0, which means it is allowed, what should I return? So here, other than writing this, I can then write, then I will return my a times the factorial of a minus 1, factorial of a minus 1. So which means I am going from one side to another. So for now, I am going to move from one to another, from one to another, from one to another, then my else. So after doing this, just cause here, if I say factorial for a minus 1, it will go back here. It does it again. You understand that a is minus minus until this a is becoming equal or less than 0. Then for this case, it will return 1. So if it returns 1, so it means then now the system will show me the result. So this is it then. So which means then here, what am I going to do? It is the same. What I am going to do, it is the same. So enter a number, I'm going to enter 5. You can see now 5 is equal to 120. So which means changing from iteration to recursion, it is very easy. So if you have any problem, you can please contact me, or even you can go to Google to search for further information about this. So I hope this tutorial was very useful to you guys, and if you have any problem, please don't hesitate to let us know so that we can clarify them. Thank you so much and be blessed. In your free time, you can please try these 4 questions to find the sum of natural numbers, to find the GCD using recursion, to check whether a number is positive or negative, and to check for a palindrome number. You can try these questions in your free time, and if you have problem, please don't hesitate to consult me. So thank you very much. This is the end of our today's tutorial, and today we talked about what is a function, and we have seen that a function is nothing other than a named, independent, and reusable set of codes that solves a specific problem. And we have seen that it is named because it will be having a specific name and it should be unique in the program. It is independent because whatever that you're running from this function will not interfere with the set or the codes or the instructions from another function. And it is reusable because you don't need to create and create again this function. You only need to call it and it will listen. The benefits, we have seen that it will break a large computing into small, or computation program into small ones, and it will avoid or even minimize the redundant programming. It will increase the quality of the program, and also it will promote portability. And here the terminologies, we have seen the prototypes. After prototype, we have seen the function definition, we have seen parameters, and we have seen arguments. Prototype, we have seen that it is the function header plus the semicolon. It is very useful when you are creating your functions after main. You have the main function and other functions are behind the main, which means you need to prototype those functions because you need to call them inside main, yet they didn't been created before main. Okay, how does function works? We have seen that the function, it is a set of those codes or programs, and the way it works is like this. We have seen it here. You can have this function, and it will have where to start, where to stop, the return type, and the function name, and this return type should be the one that you need to return. Okay, this is it. And we have seen then the lifetime of available. We have seen that it is to be local to that function, otherwise you can make it global to be accessed in all the functions. Calling by value and by reference, and finally we have seen recursion, whereby we explored how do we create a recursive function, and the recursive function is nothing other than the function calling itself. And it is nowadays a popular practice in all the programming languages, whereby recursive function also has been one of the pillar to our programming. Thank you very much. Thank you once again. Be blessed. I hope this tutorial will give you a hint on what is functions, and you can also see the next tutorial, which will also be talking about function or advanced modular programming using functions. Bye bye.